In the previous video, we calculated the shear force that was being supported by a particular bolt of 6 kilonewtons. We also then calculated Ft, so this is the force that was supported by that bolt as a result of the torque that was being applied around that section. Alright, so what I can do is I can create a simplified drawing of what's going on for this particular bolt. And so that is what I have over here. So at bolt number 1, we've got the 6 kilonewton force acting down, and this force that's being acting on that bolt, it's at right angles to a radial distance away from this point, and we can now try to calculate the resultant force, which would be the addition of both of these forces together. That's this vector here, which I'm drawing now. So to be able to do that, something important to do is to try to calculate this angle theta. So if we have a right angle triangle, we have the opposite side to this angle and the adjacent side to this angle. We can calculate this angle theta, and that's through the relationship tan theta equal to 30 divided by 100. So we can get theta equal to tan inverse of 30 divided by 100, and then try to calculate that term here. So that's going to be 30 divided by 100, and then inverse tan of the answer, and we get 16.7 degrees as the angle for that component. Now, if this angle here is 16.7, that means that the remaining angle here will be 90 minus this number, so 90 minus 16.699. So this angle here will be equal to 73.3 degrees. Then that means that this angle over here is going to be the same as theta, because there's a right angle between this part that's radially in contact with this point and this force which is tangent to this radial distance. Okay. So what we can do to find the resultant is basically we'll take this force. We can break that force into two parts. This part which is in the y direction, and this part which is in the x direction. This component here would be equal to 128.24 multiplied by the sine of this angle, which is 16.7, and this force here would be equal to 12,824 times cosine of 16.7. Okay, so to find out the resultant, we have the resultant force, which is equal to the sum of forces in the y direction squared, equal to the sum of forces in the x direction squared, and then square root of that value. So to find that value, the summation of forces in the y direction would be equal to 6 plus 12,824 times cosine 16.7. You can treat these both as minus if you want, but it gets squared anyway. Now maybe we can put them as minus. Alright, squared plus this one which is going to the left, so plus negative 12824 sine of 16.7 all squared, and we can square root that number. So the sum of forces in the y direction is just going to be minus 6 minus 12824 cosine 16.7, so round about minus 12289, and the summation of forces in the x direction will be equal to minus 12824 times sine of 16.7. Alright, so minus 3685.1 squared, and then we can square root the entire equation. Okay, so then we can find out the resultant force. So square root of minus 12289 squared plus negative 3685.1 squared, and we get 12829. So it turns out that this value has had negligible effect. Now, just double checking if I haven't done a mistake with the brackets. Okay. So here I get 12829, looking at 830 newtons, and that's our resultant force acting on that component. Alright, so assuming that that's the largest force acting on that section, we're now ready to try to calculate the size of bolts required for that section. And so we'll go through that in the next video. We'll talk to you soon. Thank you. Bye-bye.